Assalamualaikum and good morning to my esteemed panels. My name is Adiba binti Abdul Hakim from Applied Microbiology Program. Today I will be presenting my final year project, which is Antibacterial and Antibiofilm Efficacy of Caulerpa Lentillifera against Pathogenic bacteria under the supervision of Dr. Muhammad Fakarul Zahman Jayahya. Pathogenic bacteria such as Staphylococcus aureus, Streptococcus mutans, Streptococcus dysgalactiae, and Pseudomonas aeruginosa are major causes of persistent infection due to their ability to form biofilm. Biofilm act as a protective barrier, making bacteria more resistant to antibiotic and host immune response. Marine algae, especially Caulerpa lentillifera, are rich in bioactive compounds, but their antibiofilm potential against clinically relevant pathogens remain underexplored. Although Caulerpa lentillifera has reported antibacterial properties, most studies focus on general antibacterial effect rather than the ability of the extract to inhibit or disrupt biofilm formation. Therefore, my study will address the lack of data in both antibacterial and antibiofilm activities of C. lentillifera against pathogenic bacteria. From the knowledge gap, I focus on two main objectives for this study. First, to identify the bioactive compound of C. lentillifera using phytochemical analysis. Second, to evaluate the antibacterial and antibiofilm efficacy of Caulerpa lentillifera extracts. There are two important concepts. First, biofilm, which are the resistant microbial communities protected by EPS, extracellular polymetric substances that are hard to eliminate. While the second one is Caulerpa lentillifera, which contain bioactive compound that can potentially interfere with bacterial adhesion, EPS production, and quorum sensing. Several studies have demonstrated that C. grapes or Lato possesses notable antibacterial and antibiofilm properties. For instance, Coprio reported that the extract from Caulerpa lentillifera contains bioactive compounds such as alkaloids, terpenoids, and flavonoids that exhibit antibacterial and antioxidant properties. While Lee said that this bioactive compound can disrupt bacterial cell wall and interfere with the adhesion and EPS production. While Eliandi proved that Caulerpa lentillifera have antibacterial activity against pathogens like E. coli and Staph aureus, which share biofilm forming traits similar to the pathogenic bacteria in my study. Here is the overall workflow of the research, starting with sample preparation and extraction, followed by bacterial culture preparation, phytochemical analysis, antibacterial and antibiofilm testing, and finally data interpretation. To achieve objective 1, I carried out GCMS analysis to detect volatile bioactive compounds and FTIR to identify the change in spectra for biofilm. While for objective 2, I performed MIC using broth microdilution, MBC testing on tryptophan soy broth, and antibiofilm assay to measure the percentage inhibition of biofilm biomass. Next is the results. The chemical composition of Caulerpa lentillifera extract was first analyzed using GCMS to identify potential bioactive compound. For ethanol extract, the major compounds identified were neophytidine, palmitic acid, and phytol, which are reported to possess antimicrobial and antibiofilm activities. This compound commonly associated with membrane disruption and inhibition of bacterial growth. In contrast, the acetone extract was dominated by fatty acid including palmitic acid, octadecathrenoic acid, and palmitolic acid. Fatty acids are known to interact with bacterial membranes, which may contribute to the stronger antibiofilm effects observed in later assays. Based on this chemical profile, the antibacterial activity of the extract was evaluated using MIC and MBC assay. Both ethanol and acetone extract inhibited the growth of all tested pathogens, as indicated by the measurable MIC value. The ethanol extract generally showed that there are lower MIC value, particularly against Staph aureus, suggesting that Staph aureus have stronger growth inhibition. However, most ethanol extract did not exhibit bactericidal effect, indicating primarily bacteriostatic activity. In contrast, the acetone extract demonstrated bactericidal activity against Streptococcus mutans and S. dysgalactiae, which may be related to the higher fatty acid content observed in GCMS analysis. While for Pseudomonas aeruginosa and Staph aureus, it required a higher concentration for bactericidal activity. Following the MIC and MBC analysis, the antibiofilm activity of the extract was assessed. For ethanol extract, biofilm inhibition increased with concentration across all tested pathogens. Strong inhibition was observed against Streptococcus mutans and Pseudomonas aeruginosa at higher concentration, while Streptococcus dysgalactiae and Streptococcus mutans show high to moderate inhibition in biofilm formation. For the acetone extract, strong inhibition was observed against gram-positive bacteria, particularly Staph aureus, Streptococcus mutans, and S. dysgalactiae. while in contrast, Pseudomonas aeruginosa showed lower susceptibility, likely due to its strong biofilm forming abilities and lower extraction yield in the extract. Some interference with adhesion and EPS synthesis occurred but not as strongly as ethanol. These findings indicate that the extract can disrupt biofilm formation without relying solely on bactericidal activity, suggesting that they are interfering with biofilm development and stability rather than complete bacterial killing. FTIR analysis was performed to provide supporting evidence for biofilm destruction. The spectra of treated samples show changes in peak intensity compared to the negative control. There is a reduced intensity at around 1631 and 1542 cm, which are associated with amide 1 and amide 2 bands, suggest alteration in protein components of the biofilm matrix. Next, the changes are observed at 1232 and 1032 cm, corresponding to the polysaccharides and nucleic acid related functional group, which indicate possible destruction of extracellular polymerase substances. Additionally, changes in the region around 1742 cm associated with carbonyl group of fatty acid suggest that the interaction between extract component and lipid structure within the biofilm. These qualitative changes indicate that the extract may interfere with the structural integrity of the biofilm rather than completely removing its component. In conclusion, this study demonstrated that Caulerpa Lentillifera possesses both antibacterial and antibiofilm activities against pathogenic bacteria. Among the two solvents tested, the ethanol extract consistently show higher extraction yield, stronger antibacterial activity, and greater biofilm biomass reduction compared to the acetone extract. The MIC and MBC result confirmed that the extract were able to inhibit bacteria at specific concentration, while the biofilm assay showed significant reduction in biofilm biomass, indicating interference with biofilm formation. These findings were further supported by GCMS analysis, which identified bioactive compound with known antimicrobial properties, and FTIR analysis that suggested disruption of biofilm-related functional group. Overall, Caulerpa Lentillifera shows strong potential as a natural antibiofilm agent for controlling biofilm-associated infection. For future work, it is recommended to isolate and characterize individual bioactive compounds to determine their specific contribution to antibacterial and antibiofilm effects. Advanced mechanistic studies such as SEM imaging, EPS quantification, and quorum sensing analysis should be conducted to confirm the mode of antibiofilm action. Finally, formulation-based study including wound dressing, oral care, or antimicrobial coatings may be explored to assess the practical application of Caulerpa Lentillifera extracts. This is my references. Thank you very much for your attention.